Hello everyone. This is the 17th question of class 9th gravitation. It is the 17th question from exercise part. End of the lesson. Okay. A stone is allowed to fall from the top of a tower 100-meter high, and at the same time another stone is projected vertically upwards from the ground with a velocity of 25 meter per second. Calculate when and where the two stones will meet. Okay, so according to the question, two stones are there. A stone is just allowed to fall from a certain height. It is just allowed to fall from a certain height, and that height is actually 100 meter because we are dropping the stone from the top of a tower. Okay, so the height of the tower is 100 meter. Then at the same time, another stone is projected vertically upwards. Another stone is projected vertically upwards. So two stones are moving in just opposite direction, and at a particular point they will meet. Definitely they will meet. Okay, let us consider this is the point where these two stones will meet after some time t. Okay, then what we have to find, when and where the two stones will meet. So where means we have to find the distance, when means we have to find the time. Okay, and this stone is just allowed to fall means stone is not throwing, it is just falling, allowed to fall. No external force or something is there to give a force. So what we can do, we can choose initial velocity for this stone as 0. Okay, so for this stone that is falling downwards, that has initial velocity 0. And this stone, what about this stone? It is thrown with a velocity of 25 meter per second. So this one have an initial velocity that is 25 meter per second. Okay, and let us consider this distance as x. Okay, this distance from the top to the meeting point. If it is x, the remaining distance, what will be the remaining distance? This is the remaining distance, is it? The remaining distance will be, total distance is 100, and a part of it is x, then the remaining part will be 100 minus x. Clear? Okay, then let us consider the stone that is moving downwards. When the stone that is moving downwards, let us write the equations in the case of that stone. Okay, here we have to find out the distance, time, etc. We can use the equation s is equal to ut plus half at square. Okay, here we are not using v is equal to u plus at etc. because s is not there. We need an answer related to s and t. So this equation is better to use. Okay, then one more thing is there. This equation we have to replace a by acceleration due to gravity, and here we are considering that stone is moving downwards, means in the direction of gravitational force, then g will be positive. We have to take g as positive when the stone is moving downwards. Okay, so this equation can be written as ut plus half gt square. Okay, then this distance, this is actually distance traveled, and that is actually the vertical distance, is it? The stone that is moving downwards, it travels the distance x. So x is equal to, what is its initial velocity? That is 0. So 0 into, let us consider the time of meeting is t. Okay, then 0 into t plus half into, for easiness of calculation, let us use the value of 10 meter per second square as g. Okay, so g is equal to plus 10 because it is moving downwards into t square. Okay, then what we will get, this term will become 0, and in 10 2's are 5 times are there, then x is equal to 5 t square. Okay, then When the stone is, the other stone that is moving upwards, it is considered the case of the stone that is moving upwards. Similar equation we can use, S is equal to ut plus, see here when the stone is moving upward, it is against the gravitational force. So we have to choose G as negative. Okay. So here G will be minus G actually, ut plus half gt square. So this will be S is equal to ut minus half gt square because the stone is moving upward. Okay. Then what is the distance S here? For this particular stone, in time t, it is traveling a distance of 100 minus x. So 100 minus x is equal to, what is its initial velocity? It was not 0, it is 25 meter per second. So 25 into t minus half into 10 into t square. So this will become 25t minus 5t square, is it? Here also same cancellation is there. So 100 minus x is equal to 25t minus 5t square. Then this 5t square can be replaced by x, or x can be replaced by 5t square, is it? Because x is equal to 5t square. So what we can write? 100 minus 5t square, that will be equal to 25t minus 5t square. So minus 5t square and minus 5t square. When we take this minus 5t square to this side, it will become plus 5t square, is it? Or if we take this minus 5t square to the right, it will become plus 5t square. That means these two will be cancelling. Correct? Then what is remaining then? 25t is equal to 100, is it? 25t is equal to 100. I have just interchanged the values in the to the left and right. Okay. So 25t is equal to 100. 100 is equal to 25t is remaining, or we can write it as 25t is equal to 100 and t is equal to 100 by 25, that is equal to 4 seconds. So we have got the time. When it means after 4 seconds both the stones will meet, and where it meets means we have to find out which one, x or 100 minus x. We have to find 100 minus x, because why? Because ground is the reference point and we can measure the distance from ground, and it is very difficult to measure the distance from top, is it? Or from the top of the tower also we can measure. Usually it is convenient to measure the distance from the ground. Okay. So from the ground, what is the distance? It is 100 minus x, is it? 100 minus x is the distance from the top. Okay. Then what is the value of x? Either equation you can use, this one or this one, no issue, but this is the simplest one. X is equal to 5t square. Directly we can find out x. So x is equal to 5 into t is 4 second, that is 4 square. So 5 into 16, that will be 80. So 100 minus x is equal to 100 minus 80, that is equal to 20 meter. So but we can write the stones will meet 20 meter above the ground or 20 meter from the ground. Just reverse also you can write, from the tower it will meet at a distance of 80 meter. Clear?